All right, here's a quick little snippet into some of the lab activities that we do to reinforce this basic understanding of magnets. And so this first station here, you can see I'm sort of explaining to the kids that they need to look at and draw the fields around straight bar magnets and horseshoe magnets. But really the interesting station is this second one here, and you can see that we've got a setup here that looks at the fields around a solenoid. And so basically we have some coils at which we have the wire being wrapped around. And when you turn the electricity on, you can see that the iron filings within the oil move to represent the field in a solenoid. And of course you can use your right hand grip rule, as we've explained there, to work out the direction of the fields and the direction of the current. So what you do is with the right hand grip rule, remember, you get your right hand, you put your fingers that coil in the direction of the positive current. The finger therefore points in the direction of the North Pole. And so you can see that that sort of typical solenoid field you can see there. In this second station, what we're doing is we're isolating one of those coils in the oil, and when we turn it on, you can see around each section of the coil or the ring that we have a magnetic field being produced around that. And in the same sort of idea here is we can use our right hand grip rule to determine the direction of the field around each of those rings. So you put your thumb in the direction of the positive conventional current, and then your fingers will curl in the direction of the magnetic field induced. Remember, we've been talking here about that fields are induced by a movement of a charge. Well, in a wire you have movement of a charge, and even though we're using our right hand grip rule and our right hand palm rule in terms of the charge being a positive charge because it's conventional current, remember in reality it's the actual movement of electrons. So as those electrons move through the wire, they create a magnetic field around that wire. And so within this one you just said, and we'll play it again, that you put your thumb in the direction of the positive current, and your fingers curl in the direction of the magnetic field. Now of course we will see this again when we talk about parallel wires later in the module. Now this last station you can see here is where we are using I guess you could call it a square coil, but what it's trying to replicate here is that they have wires coming down in a perpendicular oil field where you have your iron filings, and as you turn the current on you will see that once again we can use our right hand grip rule to determine the direction of a field. And this is also a more sophisticated way of doing it in the olden days, where you used to just get a wire and then you'd put a bit of cardboard and the wire would go through the cardboard. You'd turn the current on, you'd get some iron filings, you'd sprinkle them around the cardboard, and the cardboard would create the friction to hold those iron filings in that magnetic field. Well, here it's a lot clearer, these magnetic fields, and we're revising that central concept that moving charges create a magnetic field. And we're using our right hand grip rule to determine the direction of that magnetic field. And we will get back into that when we talk about parallel wires and get into concepts of parallel wires being repelled or attracted. But anyway, that's it for this quick little series. Hope you had a quick taste of some in-lab stations to review that. Oh, before I go, let's just have a look at a close-up of these 3D magnetic fields, which we have as well, these magnetic models. Because you can see here that with a bar magnet, it's a 3D arrangement of the field around a bar magnet. It's not just two-dimensional, which we tend to draw and experience when we use iron filings. And the same can be said for our horseshoe magnet as well. Alright, hope that makes sense to you. Make sure you take notes, draw pictures, and I'll see you in other videos. Alright, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to flipteacher.com and check it all out, and I'll see you in the videos.